All right, good morning and welcome again to our Zoom with the HR MacMillan Space Centre. Today we have Michael and Trish here to teach us about gravity. So you guys can take it away.
Perfect. Hi, everyone. Hey, I see lots of great faces again this morning. Good morning, Natalia and Sasha, Lacey and Lincoln. Hey, Ellen, Logan, and Haley. I see you guys there. Hello, Riley, Stevensons. Yep, awesome. So, hey, everyone. So, Rachel is not here today, but instead I brought a great friend of mine from the Space Center, and his name is Michael. Give us a wave, Michael.
Hey, everyone.
Hey, perfect. So Michael has some cool things he's going to talk about today. And if you can see behind him, he even has an Earth that's peeking over his shoulder there. And he might talk about that today. So Michael, over to you, my friend. What are you going to share with us today?
Oh, I've got a really exciting talk. Thanks for the introduction, Trish. I'm going to be your substitute teacher, filling in for Rachel today. So that means everyone's on their best behavior, because I know what it's like when you got the substitute teacher in. It's a lot of shenanigans, but there's going to be a really serious topic today because we're talking about something that we experience every day. We, in fact, are experiencing it right now, and it is gravity. Can everyone say that word together? You don't have to unmute, but we're all going to say it together. 1, 2, 3. Gravity. I think I saw some of you mouthing the words there. It's a really cool word. It's a really cool topic that we talk about at the Space Center because it is really talking about the entire universe. So I'd love to do a quick little experiment with gravity right now. And what I'd love for you to do is for everyone to stand up. Can everyone stand up right now? Here's what we're going to do. We're going to do a quick little experiment. Everyone's standing. Excellent. Now what I want you to do is I want you to do a quick little jump.
Nice.
Yes, excellent. Did everyone do it? Did everyone do it, Trish?
Yeah, I saw some great jumps out there.
All right, everyone can come back and sit down. Because this was a really cool experiment, and what we just experienced was we experienced gravity on us. We have a relationship with everything around us. I have a relationship with my water bottle. I have a relationship with the chair that I'm sitting on. But there is one thing, one very large thing that is pulling on us, and that is the Earth. Yes, the Earth is what we are standing on right now. And it is the most massive object in the universe. So when we jumped up, the Earth pulled us back down, and that is the force of gravity. So I'm going to quickly go through a couple presentations, and I would love, as we're thinking about gravity, if you have any questions, we're going to get into some of these wonders, some of these questions about gravity. It can sometimes be a little bit tricky to think about it, but that's okay. Whatever you're wondering, whatever you're thinking about when it comes to gravity, just ask it, because I love talking about gravity. This is a really fun topic. Okay, so what we're talking about here, of course, is the Earth that we live on. Gravity's pulling us. Everything on the Earth is being pulled back on it because the Earth is so massive. Every day of our lives, we are experiencing gravity, okay? But the thing is, once we get out and look and start thinking about gravity in space, things get a little bit different. Here we have a picture of the Earth and we have the moon. Okay, so just like the Earth is pulling us back down, the Earth is also pulling the moon into what we call an orbit. Okay, and then if we start thinking even bigger, we have something even bigger than the Earth, which is the sun. And the sun is so big that its gravity pulls all of the planets into orbits as well, into what we call our solar system. Then if we got even bigger, we would see our galaxy, which is filled with billions and billions of suns. And you see this little picture there in the bottom right corner. That is a picture of a galaxy that is about 500 billion suns, all in a spiral, and gravity is all holding them together, okay? And we kind of think of this as kind of like the cosmic glue of the universe, a little term that we came up with at the Space Center. And here you sort of see the Earth there. It kind of looks like it's on a trampoline. Has everyone ever been on a trampoline before? Put your hands on your head if you've ever been on a trampoline. Yeah. So think of maybe like a big ball, maybe a big bowling ball, and that's the Earth there, sort of like sinking in. And then as that Earth is sinking in, everything sort of might fall down towards it. Okay. So that's kind of what we're thinking about when it comes to gravity in that sense. So I'd like to tell you a little story, because there was a guy that one day, before we really understood what gravity was, he was just sitting under a tree. And he was just minding his own business. He's like, oh, I wonder what I'm going to have for dinner today. And lo and behold, an apple fell out of the tree and bonked him on the head. And he was like, whoa, what just happened? Why did that apple just fall out of the tree? Was the apple angry at him? Was the apple like, you know what, I'm gonna take a little vacation out of this tree and I'm gonna bonk him on the head? No, apples aren't alive. It's a fruit. So something must have acted on that apple to bonk him on the head. And he started to wonder that perhaps there was this force that pulled that apple out of the tree and bonked him on the head. And this guy's name was Sir Isaac Newton. And Sir Isaac Newton, you may have heard there's an apple even named after him, a Newton apple. But this started a lot of questions, and perhaps you have a lot of questions out there at home. And this is a really great way to sort of start your understanding of gravity. You know, sitting in our tree, apple bonks you on the head. Okay, well, what about the moon? You see the moon up there in the top left corner? Why doesn't the moon just fall out of the sky? And this gets us thinking a lot about the complexities of gravity, because out in space, you may think there is gravity. Maybe there isn't gravity. So hands on your head. Who thinks that there is gravity in space? Hands on your head. Hands on your head. Who thinks there is no gravity in space? Okay, this is it's okay. You can, wherever you're at in your understanding of gravity, that's okay. I'm going to show you a little something, because a lot of people sometimes see astronauts floating around in space, and you're wondering, okay, so here on the Earth, I don't float around, so we have gravity here, and in space, they seem to float around, so there must not be any gravity there. Well, the astronauts do need to figure out that new experience. All right, so let's just go back and watch these astronauts in training. The plane is going straight up in the air, and when it does, they feel lots of gravity, but when the plane goes straight down, they can float around as if there was no gravity. And this helps us understand what's actually happening to an astronaut. As you can see, he's dropping his book on his chest, lots of gravity as the plane's going up, but oh, here goes the plane going straight down. Now they can float around as if there's no gravity. And this plane actually has a special name. It's called the Vomit Comet. And you can probably tell why they called it the Vomit Comet, because going up and going down doesn't feel too great. So this is a little preview into next week, because next week we're going to be talking about living in space. We're going to talk about how astronauts live up there, but we're really just talking about gravity this week. We'll get into lots of other questions surrounding that, some of your inquiries, because when we're out in space, those astronauts, they're falling around the Earth. The International Space Station that's going around the Earth is going so fast that it doesn't fall back down. But just like on that plane, as it's falling down, the astronauts are floating around, it feels like there is no gravity. But there is lots of gravity. Their plane is being pulled back down the Earth, but the astronauts inside, they feel weightless. So it's a bit of a complex subject. If you have questions about some of the things that I've shown you, please jump in. But that's my little spiel on gravity, and I would love to throw it over to Trish to get even deeper on it.
So Michael, I have a question for you.
Yeah.
So last weekend when it was really, really sunny, my mom took me to get some ice cream, and I had a really big ice cream cone with the ice cream on top. And I leaned over it and I took a big lick of my ice cream, and the ice cream went and fell right onto the sidewalk. So was that gravity there?
Well, I mean, yeah, it certainly is. I mean, anytime that, I mean, you can drop any object you want. Drop my, my bag here, can drop my pen there. Gravity is pulling it back down to the earth. Now, your ice cream cone, of course, is very fluid and things stick together. Like, you know, in the water bottle, water likes to stick together. So there's other forces at work, but the main force at work there is gravity.
Exactly. So my question is, if I wasn't here having an ice cream cone on Earth and I went to another planet, say Mars, because Rachel was talking about Mars, and I took a big lick of my ice cream cone and the ice cream fell off the cone, would it fall onto the ground on Mars?
Well, that's a really interesting question, because we understand gravity because we live on Earth. But gravity changes if we were to go to another place. If we were to go to the moon, if we were to go to Mars, that would totally change because those places are not as big. So the bigger you get, the more gravity you have. The smaller place you go to, so the moon is not very big, well, relative to the Earth, so they don't have as strong a gravity as we do here on Earth. And Mars is a little bit smaller than the Earth as well. So, but it's a little bit bigger than the moon. So if you've seen astronauts bounding around on the moon, they wouldn't quite be doing that on Mars, but a little bit more than they would here on Earth.
That's a really good observation, Michael. I always like to look at the YouTube videos of astronauts jumping around on the moon's surface in their spacesuit. There's some really cool videos of that. And I always like to think about, and maybe some of our friends think about that, what are your favorite sports here on Earth? What about riding your bike on the moon? Could you do a jump, Michael, and maybe probably float a little bit before you landed back on the ground? And what if you kicked a soccer ball really hard on Mars? Would it keep going really far before it landed in the goal?
Yeah. You know, I used to play this video game because my favorite sport growing up was baseball. And the video game was called Baseball Simulator, and you could play baseball in space. And I thought it was really fun because basically if you hit the ball really hard, it would just keep on going. And it was really fun to play baseball. There was lots of home runs playing that baseball simulator in space because like we said, here on Earth, lots of gravity. So when somebody hits a ball up into the air, eventually the ball is going to fall back down. But if you were on the moon, that ball is just going to keep on going. The lower gravity is not going to pull it back down, so that ball is going to go really, really far. It's really fun to think about sports.
Observation. Yeah, that's really cool, Michael. So one of the really cool things that you said today is there's gravity on the moon and there's gravity on the Earth, and the gravity is keeping the moon where it is. So the moon doesn't go flying off. Hey, where did the moon go? And the moon doesn't come crashing into the Earth. It stays right where it is because of gravity.
That's right.
Awesome. Haley, I think it might be time for some wonders. I don't know if anybody has any questions out there. Ellen, Logan, anybody? Lincoln, do you have a question?
Awesome. So boys and girls, if you do have a question, remember you can put up your hand or you can type it into the chat box and we will answer from there. So I see a couple hands up already. So Natalia and Sasha are always good for some wonders. So what's your question, Miss Natalia?
Why can't you float on Earth?
Good question. Michael will answer that for you.
Well, you can actually float. Has anyone ever been swimming recently? Yeah. So we can float on other, you know, in a pool, you know, maybe out in the ocean, because the water kind of like helps us simulate perhaps what it would be like in low gravity. But in the air, remember, the Earth is pulling us back down to the ground. So just like we did that experiment right off the top when we all jumped up, the Earth pulled us back down. Now, what happens if we want to, you know, go up higher? Well, we saw that on the plane. So we can get onto a craft that will take us up higher, but we need to have something powerful like a rocket engine or on those planes to help us take off because our legs aren't strong enough to escape Earth's gravity. But if we did have powerful legs, maybe like Superman or something like that, maybe we could. And that's actually how Superman floats, because he is so strong that he can just jump up and basically just fly around the Earth because his legs are so strong, basically kind of like a rocket ship or a plane. But our legs aren't strong enough. So unfortunately we can't, which is too bad because I would love to float around on the Earth. But
that's a pretty cool observation about the pool, Michael. So next time our students go swimming, they can practice floating as if they were in space. So Michael, we talked a lot last week about living in space, and we showed some space food to our friends, and we showed, I think, some mission patches, and we talked about what astronauts do. But one of the things that astronauts do certainly is a lot of training before they go to space, and they do a lot of practicing in a pool here on Earth. So they have a really huge pool in the United States where the astronauts can actually put on their whole spacesuit and go under the water. And that's where they do a lot of training, because your arms float in the water and it gets them used to working in an environment where everything is floating.
I can maybe do another experiment here if you want with gravity.
Sure, let's do an experiment.
All right. So what I would like to ask everyone is, let me see if I've got two objects here. And you can maybe do this experiment at home. I have my phone and I have this little pin. Now the question is, which one of these is heavier? Who thinks, hands on your head, who thinks the phone is heavier? Okay, does anyone think that the pin is heavier? No, everyone, the phone is heavier than the pin. So the question is, if I drop these two objects, which object would hit the ground first? Hands up, who thinks the phone is going to hit the ground first? Hands up, who thinks the pin is going to hit the ground first? All right, so let's do this experiment. I'm going to show my table here, and I'm going to hold it up high. You can probably do this at home with two safe objects.
Yeah, so what are some objects they could try? Maybe if they were outside, Michael, they could grab one rock and one ball and see what would hit first.
Mm-hmm. So let's do this experiment. Hopefully you can see this. I'm going to pull my microphone out of the way here. Let's see. Let's do a count of 3. 3, 2, 1.
Hey.
Did you see?
Yeah, they both hit at the same time.
They both hit at the same time. Now this is another classic experiment that a guy named Galileo, he would go to the top of this tower called the Leaning Tower of Pisa, and he would drop two heavy objects. He'd drop a really heavy object and a really light object, and they both would hit at the same time. And he discovered that the force of gravity is equal on objects that are lighter than are heavier. And he was like, oh, this is really weird. And people would watch this and like, I think I can fool you, because what if I dropped something like a feather or something like this, and then I dropped the phone? Which one's going to drop first? Who thinks the phone?
Phone, yeah.
It does, yeah. And if I drop them, you would see this sort of like floating down, and the phone would hit harder. So why is that happening? Well, there's another force that's happening, and it's all this stuff that my hand is going through right now. All this stuff is called air. We have this air that my little rag here, it would kind of float down. But you know where there isn't any air?
Space.
the moon. Yeah. So I'm going to show you another cool little video here. An experiment that was done by an astronaut on the moon.
And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather.
So he's got a feather and he's got a hammer.
And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that?
Whoa.
Mr. Galileo was correct in his findings.
So Michael, the feather and the hammer dropped and landed at the exact same time on the moon.
Exactly. Just how we did that experiment with my phone and the pin. And if you go outside and find a heavy object and a light object, they will hit the ground at the same time. But if you use something that might float in the air, like a feather or like my rag here, air is going to slow it down. But if we took that experiment to the moon and we dropped my phone and my rag at the same time, there's no air and they would also fall at the same time.
That's a pretty cool experiment, Michael.
That is a pretty cool experiment. I wonder if our boys and girls maybe today or sometime later may want to try that experiment and perhaps get their parents to record them doing it, and we can see what objects other people have tried. They can tag Learn Fort Langley and the Space Center in the video, and we can check out what objects fall at different speeds.
Yeah, that'd be
That's
great.
Great, Haley. Yeah.
Although I do recommend that you don't use your cell phone for drop-in.
Yeah.
You trust
Because I have a nice protective case here, so I knew it was going to be okay.
Yeah, I drop my phone all the time, and gravity is very consistent in taking it all the way down to the ground.
It is.
So, boys and girls, this is one last chance for questions before we wrap up today with the Space Center. Does anybody have a question about gravity or anything else? Natalia and Sasha.
Oh, okay.
There
I was
we are.
wondering if anyone's been outside and observed any stars or planets or even the moon in the last week or so. You have to look when it's clear outside.
All right, Talia and Sasha, what's your question?
We can't go outside and do this experiment because it's raining here.
I know, but you know
Oh.
what? There's going to be some sunshine this weekend, Natalia. I checked the weather. So when it's okay and your parents say you can, maybe go outside in between the raindrops and see if you can do an experiment.
Now, I wonder, is gravity what is pulling the raindrops down to Earth too?
Absolutely. That's a great observation. Yeah. Though that water is really light, and say as soon as it's formed in the clouds up there, the gravity is just pulling it straight down.
So I wish there was less gravity in our area so it rained less.
But you know what's an interesting observation there though is if you take snow, which is a little bit fluffier, water is actually heavier than snow. Snow kind of like it's very fluffy. So as it floats down in the air, it floats down slower than say like the rain would, because the rain is heavier. So that's why we sort of see that the snow kind of float down, because all of that air is in the way and it comes down slower than say the rain would.
So if it snowed on the moon, which I know it can't, but
Yeah.
would you imagine that the snow would hit the ground the same time as the rain because of the air's not there too, right?
Exactly, yeah. And that's really interesting because we look at weather on other places. Now, the moon doesn't have any clouds or atmosphere, but there are worlds that do. And one of those worlds is called Titan, and it's a moon of Saturn, and it does have this atmosphere, and they have observed this weather phenomena. And the gravity there is a little bit lower than, say, here. But yeah, the rain, the snow doesn't really fall the same way. It's just sort of like this fog that it kind of just like it sheets down. It's a very strange weather pattern. It's instead of like seeing the objects like fall down like the snow and the rain would, it's just kind of like this sheet of fog that just sort of like floats down altogether.
Awesome. So thank you very much for joining us today, Michael and Trish. We really always appreciate your time with us. So
Thank you for having us.
Yeah.
you need to say goodbye. So if you could wave and say goodbye,